Okay, go. For our real-life example, we captured a video of Evan tossing a ball while riding a bike. We recorded it with a frame of reference attached to the ground and a frame of reference following Evan. As you can see, when the camera is fixed to the ground, the ball follows a curved path, and when the camera follows Evan, the ball goes straight up and down. With a frame of reference attached to the ground, to find the initial velocity of the ball as it is thrown up, we measured the distance it traveled over 2 frames, using the length of Evan's forearm as a reference. We calculated that the ball was moving at 5.52 meters per second, and measured the direction to be 65 degrees above the horizontal. We then found that the velocity was the same when the ball landed, except the direction was 65 degrees below horizontal instead. The horizontal component of the ball's velocity was the same at the beginning, end, and middle of the throw. The horizontal velocity of the ball was 2.33 meters per second, the same speed that Evan was riding his bike. When the frame of reference was following Evan, we used the same method as before to find the initial velocity. We found that the ball was moving up at 4.63 meters per second over the first 2 frames. There is no horizontal movement at all, unlike the other video. However, just like the first video, the ball and Evan have the same horizontal velocity, but in this case, the horizontal velocity for both Evan and the ball is 0. This time, when the ball is at the peak of the toss, it is perfectly still, relative to Evan. When the ball lands, it is traveling at 4.63 meters per second again, but going straight down this time. Notice that the ball stayed in between the 2 lines the entire time. In conclusion, while it may look like Evan is throwing the ball forwards, from Evan's frame of reference, he's actually throwing it straight up.